Well, good morning, everybody. A small audience. Let's see if I can wake you up early in the morning. Last day of the conference. I want to talk about something a bit different this morning. I want to talk about the role of environmental chemicals in the development of breast cancer. Breast cancer is not a new disease, as we know, but incidence continues to rise, and we've heard that many times in this conference. Here are the figures for England and Wales. Incidence continually going up. The question is why? Risk factors have been identified, but the causes remain unknown. And at the end of the day, until causes are known, prevention cannot become a reality. And that is why we're all here, to try and put ourselves out of a job so that breast cancer no longer exists. So the risk factors for breast cancer are genetics. Certainly being female is a risk. Loss of function of the BRCA1, BRCA2 genes, or indeed other DNA repair genes. Diet, alcohol, radiation, obesity, all risk factors for breast cancer. But the biggest risk factors remain hormonal, and in particular lifetime to exposure to estrogen, be it through age of puberty or menopause, issues surrounding the age of your first child or whether you breastfed or not, and personal decisions to use oral contraceptives or hormone replacement therapy. So what about chemicals from the environment which we know can enter the human breast? And many hundred of them have now been measured in the human breast. If exposure to estrogen is a main risk factor, how about exposure to estrogenic chemicals, which we know can get into the human breast? So where do they come from? Well, estrogenic chemicals can enter the human breast from a range of different sources these days. Not only oral contraceptives and HRT, but they can come from the outdoor environment through use of pesticides and herbicides, from diet, through agrochemicals, polychlorinated biphenyls or dioxins that get into fat of the diet, plant estrogens, and indeed we're surrounded by things in the indoor environment in the form of household products. Bisphenol A and phthalates of plastics, the polybrominated diphenyl ethers, which are used as flame retardants in all our internal furnishings, non-stick coatings on cookware, stain resistance coatings again on all our soft furnishings, and detergents, the alkyl phenols. And in addition to this, I've proposed the dermal absorption of personal care products may add on top of this. Parabens and triclosan used as preservatives and deodorant, aluminium used as antiperspirant, UV filters used to absorb UV light, musks, lilial, benzyl salicylate, all the fragrance components, cyclosiloxanes, and anti-aging, which is often ethinyl estradiol itself. All these components here have been measured in breast tissue. All of those there are estrogenic. Could they play a role in breast cancer? Our breasts are polluted in the modern world. Well, say people, could these estrogens ever have any effect on human health? It's very nice to have some situations where you can reverse the situation and look at that. Cancer, of course, is a one-way road. But we do know that women who were prescribed diethylstilbestrol during pregnancy in the 1970s have increased breast cancer incidence, and their daughters, who were only exposed in utero, also have now increased breast cancer incidence. So this tells us the score if we are exposed to a potent estrogen, either during life or in utero. Some of these other examples are examples of disruption of endocrine systems rather than cancer. And so it tells us that if something's happening, we may be able to reverse it. The Mortician's Mystery is an interesting one. It was published in 1988, showed a chap working as a mortician using embalming creams. And he was absorbing chemicals from these creams, caused him to appear in the clinic with loss of libido, decreased testicular size, and marked breast development. This was sorted out simply by telling him to wear gloves when he did his job. There's a case of a 36-year-old girl going into enterthalicity from exposure to her mother's shampoo. This was sorted out simply by the mother not using that shampoo. Abnormal bleeding in a 93-year-old after using an ethinyl estradiol-containing body cream, messing up her systems. Unfortunately, that one was not reversed because she went on to develop breast cancer as well. But these and many more cases now exist of endocrine disruption, showing these chemicals can get into the human body and can impact on endocrine systems. And if you want to read more, my book has just been published. It's an edited book with a lot of contributors called Endocrine Disruption and Human Health. I've got a copy over there if you'd like to see it, and the advertisement is on the back page of this conference. So what about cancer? Could environmental chemicals influence also the development of breast cancer? If we're looking at breast cancer, are there environmental chemicals getting into the human breast with estrogenic activity? Maybe some without. They weren't designed to be estrogens, these things that we use around the house all the time. Could they damage DNA and cause initiation? Could they enable promotion? Could they enable tumour growth? Could they enable tumour spread and growth of metastatic tumours? Or if you want to look at it another way, Hanahan and Weinberg have described a range of hallmarks of cancer. 6 basic hallmarks, 2 emerging hallmarks, and 2 enabling characteristics. Could these chemicals, either together or individually, impact on one or more of these hallmarks so that together they can cause cancer? Maybe not alone, but together. And we're looking at things like sustained proliferative signalling, resisting cell death, inducing angiogenesis, enabling replicative immortality, activating invasion and metastasis, evading growth suppressors, deregulating cellular energetics, avoiding immune destruction, and the enabling characteristics of genome instability and mutation and tumour-promoting inflammation. What about these chemicals? Well, I proposed a new hypothesis in 2001. This isn't to say this is the only component of breast cancer. This is adding on top of the burden of pollutants we know we have in the human breast. I proposed that underarm cosmetics, these things that go under the arm every day in such a ton these days, could contribute to causality of breast cancer, based largely on the disproportionate incidence of breast cancer in the upper outer quadrant. More than half of breast cancers in the United States and the United Kingdom occur in this upper outer quadrant. Why? Why isn't it distributed equally? Okay, there's a little bit more breast tissue in that region than other regions. But when I looked at publications, the year of publication seems to indicate that this disproportionality is going up. So I then looked at individual populations where we have returns on quadrant incidence every year, and England and Wales, and separately Scotland. I've done it also now on the SEER database for the United States. Same thing, it's going up. So this sort of rising incidence is inconsistent with an explanation of it being merely due to more epithelial tissue in that region. There's something else going on as well. Could it be chemicals that are being loaded in that region? My case for the involvement of cosmetic chemicals surrounds issues of exposure because they're applied directly to the underarm and the breast area where we have all the tumours developing. They're left on the skin, they're not washed off, so that allows for continuous exposure. And they're contained, yes, in antiperspirants and deodorants, but the same chemicals are in a ton of other things. Just look on the supermarket shelf. They're in body lotions, body creams, body sprays, moisturising creams, breast firming and enhancing creams, tanning creams, sun care creams. All these things go on around the breast, under the arms, every day. What we've got is a situation of chemical overload and individual susceptibility. And that's quite easy in a culture where we're persuaded to use ever-increasing frequency and quantity, and that's not only in the Western world, that's now being advertised out to the Eastern world as well. And they're being used by ever younger children and by babies, particularly susceptible subgroups. If I'm looking at molecular mechanisms, I may be looking for the hallmarks of cancer, but in particular I may be looking for chemicals which are genotoxic and can damage DNA, chemicals which possess estrogenic activity and can cause cell growth. At the moment, the dogma is fixated that if breast cancer is caused by a single chemical, that chemical has to be at high levels in the breast where the tumour is and nothing else is involved. Unfortunately, if it were that simple, someone would have sorted it out long ago. It isn't. It's about long-term, low-dose exposure to mixtures of chemicals in this world where our breast is highly polluted. There will be different absorption, metabolism and clearance of each of the chemicals. And of course there has to be a consideration of timing of exposure because we know the breast is particularly susceptible to cancer prior to puberty. So I'm going to talk about a couple of chemicals in these products. You have to start where you are. You can't start with such a big question in the middle of the air. So I've started by looking at some of the chemicals and then trying to mix them. So I'm going to talk a little bit about our work on parabens and aluminium. Believe me, that's not where we're stopping. We're going on to other chemicals, and indeed, one of my students had a poster on one of the fragrance components yesterday. Parabens are the alkyl esters of parahydroxybenzoic acid. They're used in personal care products, foods, pharmaceuticals, and now even in paper. To preserve them, there are 5 routinely used parabens and there's benzylparaben that's also used. What have we done? Well, we've shown that parabens have estrogenic activity in vitro and in vivo assays. And remember, lifetime exposure to estrogen is the main risk factor for breast cancer. We've measured them as present in human breast tissue. And we're now looking to see if they can enable multiple hallmarks of cancer to develop. In terms of evidence for their estrogenic activity, most of this is published. But to summarise, we've shown that all the parabens can bind to estrogen receptors. Yes, more weakly than estradiol, the main hormone, but they can bind. They can regulate estrogen-responsive gene expression. They can increase growth of estrogen-dependent human breast cancer cells. And in the uterotropic assay, they can increase uterine weight in the immature rodent in vivo. One of the things that's often levied at parabens is, oh, they're weak estrogens. Dismiss them. They're so weak compared to estradiol. They couldn't possibly do anything in the human breast. Wrong. They actually bind to the estrogen receptor very, very much more weakly than estradiol. But they do not have low efficacy. Their efficacy is actually similar in terms of growth of human breast cancer cells, is similar to estradiol. What is different is that you need higher amounts of them. This is dose here in molar concentration. You need higher amounts of them than estradiol because they bind more weakly to the estrogen receptor. So the question is not to dismiss them as they couldn't do anything. The question is how much is in the human breast. And you'll be surprised when you start to measure these chemicals. I've been very surprised just how much is in the human breast. Hormones work at nanomolar concentrations in the body. These things are not at nanomolar concentrations in our body. They're much higher. They're getting in from the environment. So we upset everybody in 2004 by taking 20 human breast tumour samples and doing a pioneering study and showing we could measure 20.6 nanograms per gram of tissue in human breast tissue. We did a larger study in 2012, taking 160 samples. This was 4 serial locations across the breast from 40 patients with breast cancer. So it was across the breast here. And we measured 1 or more paraben in 158 out of 160 of the samples. And 60% of them contained not 1 paraben, but all 5 parabens. We got a higher median level than we did here of 85.5 nanograms per gram. Median levels were highest for propyl paraben and methyl paraben, which is in line with plenty of other studies now coming on looking at other human tissues. These are the parabens used most frequently in consumer goods. Higher levels of propyl paraben were found in the axilla, this region compared to this region, slightly, but statistically significant. The levels of the paraben were very, very varied. High levels of one paraben didn't associate with high of another. It was just patchy. If you looked at things across the breast of a single woman, it varied. If you looked at the same region in the breast in different women, it varied. But the question is, are these parabens at functionally significant levels? And if you look at the region where the tumour was in women, could there have been enough paraben to have stimulated growth of their tumour? And the answer is yes, in some. So this is the same graph I showed you before, now colour-coded for the 5 parabens, and I've put coloured bars under here according to the range of concentrations of paraben that we measured in the human breast tissue. So we measured everything from nothing up to this level of methyl paraben, and so on for the others. And you can see that the concentrations of methyl paraben in some of the tissues, but not all of them, could have stimulated growth, assuming parameters were the same in vivo as in vitro. And the same for propyl paraben. So we have a feasibility that there is enough in some women's breast tissues to cause proliferation of breast cancer cells. But that's looking at single parabens. We measured 5 parabens in 60% of these breast tissues. And if you do this experiment in vitro and you add these 5 parabens at low concentrations like this, you get just a small amount of proliferation of breast cancer cells. If you then mix all 5 together, you get an additive effect. What about in vivo? So what we did then were the naughty experiments. We took the concentrations of parabens as we'd measured in the breast tissue at the site of the tumour in these women, and we did some in vitro work at those concentrations and asked if those concentrations in the women could stimulate growth of the breast cancer cells in vitro. And in this particular patient who had a tumour in the mid-region, when we added them all, there was indeed enough methylparaben to stimulate growth of the cells above control. In this patient, there was not enough of any one of the parabens to stimulate above control. But when we mixed all 5, and we'd measured all 5 in her tissue, here, then there was enough to stimulate growth. Patient 20 had a tumour in the lateral region, and it was possible to have enough propylparaben, or indeed butylparaben in her case, to stimulate growth above control. And this patient had enough propylparaben to stimulate growth of the breast cancer cells. And this is without all the other chemicals that are getting into the breast. The other thing is, when we do these assays in vitro, we do them over 7 days or 14 days. But we measured parabens in 158 out of 160 of these breast tissues, which suggested we didn't take it at any particular time when women had just loaded themselves. So it suggests that parabens is there. Parabens have been measured in 96% of human urine samples in the United States. They're there throughout our body all the time. So why stick at 7 or 14 days? These are for the patients, patients 6, 7, 14, 17, 24, 35, 39. And we mixed all 5 parabens at the concentration that we measured in that tissue. And yes, over the 7 or 14-day assay, we didn't see any effect as is proliferation on proliferation. But when we left those cultures longer, then compared to no paraben, we started to see growth in some of these breast cancer cells. So not only can you mix the parabens, but if you leave them longer, you can start to see effects on growth. And that's the environmental reality. These things are present at low levels in the long term in the human breast. So my conclusion on parabens is that parabens have estrogenic activity in vitro and in vivo. Lifetime exposure to estrogen is the main risk factor for breast cancer. They have been measured in human breast tissue, and they can increase proliferation of breast cancer cells in culture at concentrations you measure in the human breast tissue. We've then been looking at other cancer hallmarks, and we've shown that they can turn non-transformed cells into transformed cells, and they can also lead to alterations in cell motility and migration, which is important for metastasis. In terms of a case for involvement of antiperspirant salts, the human body is exposed to aluminium from a range of things, diet, personal care products, vaccine adjuvants. But as underarm antiperspirant, they're applied to the breast area at high levels. We know aluminium chlorohydrate can be absorbed through human skin. It's been measured now in several human breast structures, human breast tissue, milk, nipple aspirate fluid, and breast cyst fluid. We know aluminium is genotoxic, and it's a metalloestrogen, and it can enable several hallmarks of cancer. So we measured aluminium in breast tissue, again very varied, between 4 and 437 nanomoles per gram of dry tissue, and again measured higher levels in the outer region than the inner region. Higher levels were measured in nipple aspirate fluid in patients with cancer versus no cancer. And if you took the concentrations that were measured in the nipple aspirate fluid, you could find that in vitro you can turn non-transformed cells into a transformed phenotype, and they grow in suspension culture. Furthermore, you can do migration assays where you take a culture of cells, wound it, and watch the wound moving. It's a measure of migration. And not short-term exposure, but long-term exposure to aluminium increases in these red bars over control the movement of the cells. Furthermore, more recently, we've been looking at the expression of BRCA1 protein in these non-transformed cells, and found after long-term exposure to aluminium a reduction in BRCA1 protein. So aluminium can also influence human breast cancer cells. The human breast is exposed to it because it's measured in breast tissue structures. It can enable multiple hallmarks of cancer. It can cause DNA double-strand breaks and turn breast epithelial cells into a transformed phenotype. And it can result in loss of BRCA1, which we know is a risk factor for breast cancer. This shows that BRCA1 can be reduced not only through genetics, but through exposure to environmental chemicals which are getting into the human breast. And interesting, aluminium can also increase migratory and invasive properties of cells in culture, which may also impact on metastasis, and that together with the parabens, which also did. So if we build up now in summary a bigger profile, these are the 8 hallmarks of cancer as defined by Hanahan and Weinberg, and the 2 enabling characteristics here, and we start to ask which ones can be influenced by paraben or aluminium. we start to build up a bit of the pieces of the jigsaw. What if we can now measure all the other chemicals which are contained in underarm cosmetics, of which there are a fairly large number with not a very safe history, and for which data is coming up in the literature of measurement in breast tissue and their impact on breast cancer cells. So finally, I conclude that many environmental chemicals are found in the human breast. I think this is probably because the human breast is a fatty organ, many of these chemicals are lipophilic, and the breast is frankly polluted in the modern world. I think it should surprise us not how much breast cancer we're getting, but how little when the breast is so very polluted. Perhaps this also explains why breast cancer is the main cancer of women. Some environmental chemicals do possess estrogenic activity, which can enable growth of human breast cancer cells. Some are genotoxic, able to damage DNA, and even reduce BRCA1 and other DNA repair capability. Some can increase motility and invasion, which may impact on the ability of the cells to metastasize. But since so many environmental chemicals have now been measured in the human breast, not just the ones I've talked about, but many of the others I showed you in that first slide, there is the potential for long-term exposure to mixtures of chemicals where each are present at low levels. And if reduction in exposure is possible, then this may offer a new option for prevention of breast cancer. And I would refer you to reading this review if you want to read more. This is something called the Halifax Project, which I've been a part of, which has been coordinated from Halifax, Nova Scotia in Canada. It's involved 174 scientists from 24 different countries. And we have just now produced a series of 11 review papers, which were published in June this year in Carcinogenesis. And these papers were designed to look at the evidence linking low-dose exposures of chemicals to each of the hallmarks of cancer. So each of those review papers takes a hallmark of cancer and asks, what is the evidence that low-dose exposure to chemicals could cause those hallmarks of cancer? I put to you that this is a very important aspect to research. Thank you.